Hello guys, and in today's video I will be showing you guys how to make your very own first-person rigid body controller. Now this is my first time doing like one-off tutorials, so we'll see how it goes, but yeah, I'm really excited to do this. So actually, before we start, let's actually create some things that we're going to be needing. So we can actually just delete our main camera, and what we can do is we would want to import a plane for our player to stand on. So we can just have a plane in here. Let me just make this 5 by 5 by 5, and then I'm actually going to turn down the light a bit to like 0.8 maybe. And then what we can do is we can drag in a cube, so we can create a new cube. And what we're going to do to this cube is we're just going to make this slightly bigger on the Y scale. So I'm just going to make this like, let's say 3. And if you're satisfied with the 3 or a vertical, because this vertical value for our Y scale will pretty much determine essentially how tall your player is going to be. So again, you don't have to make it 3, but this number is like completely customizable. And what we're going to do is we're going to add a rigid body to our cube, and we can actually change this to be called player. And when we do have the rigid body, we can right click on player and import a camera, and you can change this camera to be, on the proper height, but I'm just going to move it around here. And now when we press play, if you have followed every single step, you should be able to spawn in with our player. But you'll notice a couple of things. One of the first things is that you can't actually move around. And another thing is that you can't also turn your camera around to look around. And that's not good. So what we're going to do is we're going to make it so that our player can move around, rotate, jump, and do all of the things that a first-person controller should be able to do. So I'm just going to right click and create a C# script, and I'm just going to call this rigid body controller. Now obviously you guys can call this whatever you guys would like, but again I'm just going to call it rigid body controller. And I'm just going to enter the script, and actually before we do any coding, let's just drag our rigid body script onto our inspector, enter the script, and let's actually just delete these two functions. So what we can do here is let's actually type in void update. So let's just add the void update function back, and what we can do is we can say let's actually just make our movement first. So what we're going to do is we're going to create a couple of variables. So here I'm just going to create 4 public variables. So I'm going to create 4 key codes for W movement, or forward movement, backwards movement, left movement, and right movement. And then what we can do here is if input, so we're just going to make the movement of like WASD first. So what we're going to do is we're just going to type if input dot get key down, or get key actually, key code, or actually no, we don't even need key code because we can just pass in our forward movement. So if we get our forward movement input, then what we're going to do is we're going to move forward. So what we're going to need to do is, because this is a rigid body controller, how our controller is going to move around is that we're going to be applying force to it. So let's make a reference to our rigid body component, and we can say public rigid body rigid. And what we're going to do to rigid is we're going to say rigid dot add force. And we're going to add a forward moving force, so we're just going to say transform dot forward. And then we're going to create a new variable here, a float, and we're going to call this movement speed. And this variable will control how fast we move. And we're just going to multiply our transform dot forward by movement speed. And then else if, what we can do is we can say if we get an input of if we get an input of backwards movement, then obviously instead of adding a force forward, we're gonna have a negative transform dot forward force. And the reason we have transform dot negative is because there's actually no transform dot backwards option. There's only transform dot forward, up, and right. So whenever you want to do the opposite of one of those movements directions, you just type negative. And else if we can pass in our left movement, and then if we are trying to move left, then we can add a force for negative transform dot right times the movement speed, and then else if we get a key for right movement, then we're just gonna add a force for transform dot right. And now we can go back into Unity, and we should be able to, if we set all of these things, all of these key codes, we should be able to move. So this is really neat because it allows you to change like the keybinds, and this is like really useful if you have like a keybind screen in the future for like maybe like if you want to like edit your player to be able to edit keybinds for certain movements. Then yeah, this is like a really simple way to do that. So actually, I'm just going to set it all as a default. So forward movement will obviously be W, and you guys can set this as whatever you want, but I'm just going to make mine WASD for simplicity's sake. Oops. Okay, this is actually quite confusing. Okay, there we go. There's A, and then, oh sorry, no, that is backwards, so it should be S. Scroll all the way down. Yeah, the scrolling on this is like really weird, but and this should be A because it's left movement, and then right movement should be D. Oops. So right here, and then we will drag our rigid body into a rigid body slot, and we'll change our movement speed to, let's say, 500. And then now when we press play, I'm just going to drag out the game view so that you guys can see me actually moving around. So if I press W, I just moved super fast. And the reason we're moving super fast is because there's actually no lock on rotation. And what this does is that we're actually applying a force forward when we press the W key, and because we're allowed to rotate, the force is applied right here at the center of our rigid body, which means that it's going to be toppling over because our object is actually really tall. So if we actually freeze our rotation and drag our game view back, we will actually be able to see ourselves not fall when we move. However, we're just going to be moving super fast after the touch of a W button. So I'm actually going to turn this down. I'm going to turn this down to 100. So now, if we press play, you can see we are still moving, and I can move around depending on what key I'm pressing. However, you may find that we are actually accelerating exponentially because we're just adding a force and it won't stop. And so what I can do is if I press like just one key, I let go already, but our player kind of slides a little bit after I let go instead of stopping dead like it should. So how we can combat that is we can say else we're going to set the rigid body's velocity to be equal to a new vector 3 of 0, 0, and 0. And we can do this before we ever add a force. So we're going to kill all of the force before we even actually start moving. This way our force does not build up exponentially and allow for sliding, or like if we have two inputs at the same time that we're holding down, then we're not going to be accelerating really, really quickly. So now if we press play, you can see that no matter what I do, even though I'm holding down, we move at a constant speed. So I'm actually going to turn this up to 250 because it's a bit slow. But yeah, so if now instead of like sliding, our player stops as soon as I let go, which is exactly what we want. So I'm actually just going to set this to 250. And yeah. So now let's actually move on to jumping. So what we can do is we can say instead of having all of this here, we're just going to create, so we can say this is movement. And up here, we're going to have jumping. And for jumping, we can also create another key code for the jump button. So jump movement, and we can say here if input.getKey jump movement. So if we have detected the jump key, then we're gonna set our rigid. Actually, no, we will not set our rigid velocity to be equal to 0. What we will do is we will add a force of transform.up, and we're going to create a new float variable for our jumps force. So jump force, and we're just going to multiply transform.up by jump force. And after we do that, what we can actually do is we need to be doing something called a ground check. And the reason that we're going to be needing to do something called a ground check is because this bool checks whether or not our player is still on the ground and whether or not we are actually allowed to actually jump. So I'm going to set this to be default to be false, and we're going to make it so that only when you're, to be default to be true. Sorry, my bad. Just change this to true. And we're going to set this so that only if ground check is true are we allowed to jump. And as soon as we jump, ground check will actually be equal to false. And as soon as ground check is equal to false, let's actually move this up here. As soon as ground check is equal to false, we're actually not going to have any of the velocity to be killed. And the reason we don't want velocity to be killed is because we actually want our player to jump and like move up at a constant speed. Now, I'll show you what's gonna happen if we don't have the ground check in place. If I kind of try to jump right now. Oops. Let me actually turn up the jump force to like 500. So if I jump right now, I'm just gonna set ground check to be equal to true. You can see like I'm pressing space, but oh sorry, I didn't even set the. That's my bad. I didn't even set the button for this. It should be space. So if I press play, I'm kind of jumping right now, and what's happening is, let me just set this to be true. You can see, yeah, it kind of like jumps a little bit, but it's not jumping that much. And the reason for this is because we've set it so that as soon as we detect that there is no input, we kill the velocity, which is not what we want. So what we're going to need to do is we're going to have to create an if statement here that checks whether or not we are on the ground right now. So we can have if ground check here, and if we are on the ground, then we're going to do all of this. Otherwise, we're going to kill all other velocity, but we're actually going to leave our rigid body velocity's y value to be. And we can actually just copy this and paste it inside every single line right here. And now, if we go back into the game, you should be able to actually see us be able to actually jump. So let's just wait for our player to get on the ground. And also the reason it's falling slowly is because we are still killing velocity because ground check is actually true. So if we jump, we can actually jump now. But you'll see that if you're following along, that we actually cannot jump again. And that's because we haven't made it so that our ground check can actually be, re-triggered to be turned into true when we do hit the ground. So how we're going to do that is we're going to create a little box on the bottom of our player, and I'm just going to drag this down. And what we're going to do is we're going to turn off the mesh render, and we're going to make this guy, let's say 0.01 in height. And the reason we're making him 0.01 in height is because we don't actually want this to be too thick. And we're just going to drag him up right here. And then we're going to make this a trigger as well. And we're going to create a new script, and we're going to call this ground check. And And this script will pretty much tell our rigid body controller script whether or not we are grounded. And what we can do is we can create a private rigid body controller variable. So we can just call this rigid. And then on void update, or on void on trigger enter, what we can say is if other.tag is equal to ground. So we're going to create a new ground tag in the future. So if we have actually entered the ground, then what we're going to do is we're going to set, what we're going to do is we're going to set rigid dot is grounded. Is grounded. Oh, sorry, ground check. That's right. Rigid dot ground check to be equal to true. And void on trigger exit, we're going to set the ground check to be equal to false if the other game object that is triggering is actually of the tag ground. And now, if we go back into the game, we can actually change the name of this to be ground check. And then we can actually just drag our ground check in here. And we don't need to put anything in the inspector, and it should work fine on its own. So now we're going to change the ground, and you want to change everything that you want to be a ground to the ground tag, because otherwise it will not trigger our newly made ground check code. And what we're going to do is we're just going to set everything that we want to have a ground check, or to trigger the ground check to the ground tag. And then we're just going to come here and tick off our ground check by default. And now when we press play, oh, that's right. So we actually did not set our rigid variable. And I actually forgot to do that. So what we're going to do is we're going to go into void start here. And we're going to set rigid to be equal to find object of type rigid body controller. And basically what this does is that it finds the instance of whatever we're trying to look for inside the scene, and when the game starts. And now when we press play, we should be able to jump. Ground check is false, but it's true when it hits the ground. And now we can freely move around in the air. Yeah, so that is cool. And now what we can do is 3 more things. So 1, we're going to make running. 2, we're going to make it an option so that if you are in the air, you'll actually move slower, so air movement is decreased in the air. And 3, we're going to make camera movement so you can rotate around and view your world. Obviously in the first person. So we're just going to do the first 2 first. We're going to make a run speed and also an air time, like when you're like a dampener for movement in the air. So what we're gonna do is we're gonna create 2 new floats. One is gonna be called air dampener, and the other is going to be called run multiplier. And we're gonna create a new bool, and we're gonna call this is running, and we're gonna set this to be equal to false on default. And on void update, we're gonna create a new area here, and we're going to call this running. And what we can do is we can create another key code, and we can call this running is running, or running movement. And we can say here, we can say if input dot get key running movement, then we're going to set is running to be equal to true. Else we're going to set it to false. And now what this is going to do is we can create an if statement here for when we add force. We can say if is running. If we are trying to run right now, currently, then we can actually add, or sorry, if not is running, we're going to add the normal force. Otherwise, if we are going to run, then we're just going to have add the force multiplied by our running multiplier. So times multiplier. Whoops, run multiplier. And yeah, so now we can just copy this for every time we add force and just adjust it so that it fits the scenario that it is in. So for here, instead of having transform forward, we would have negative transform dot right, as well as negative transform dot right here as well. And then we would also have here transform dot right here. And now when we press play, we can see. Oh shoot! We also do need to set our running movement key. So I'm just gonna set this to left shift because that's usually the standard in most video games. So I'm just gonna try to find left shift, which is right here, and we're going to set our run multiplier to be 2. And now when we press play, if we hold down shift, you can see is running is toggled. So if is running is toggled, we're moving like super fast, but if it is not toggled, we are moving slowly. Or not slowly, but less slow than when we are not running. Yeah, so that's pretty cool. And the final, or not the final, but the second last thing we're going to do is we're going to make it so that you obviously move slower when you're in the air. So what we can do here is we can copy all of this so that we can paste this when we are in the ground. If we are not in the ground, then we're going to add a force here, but instead of multiplying by our run multiplier, we're going to divide, or we're going to multiply, or sorry, we're going to divide by our air dampener. And yeah, so basically if you make air dampener 2, your movement will be decreased to by 50%. And obviously depending on what you choose to make the variable as, your air dampener will, you know, differentiate depending on whatever you set it to be. And let's just put an air dampener here. And then we're just going to copy this again. Paste this here. And then copy this. Change this from multiplied to divided by air dampener. And then finally for our last place here, we can just paste that in. And then air dampener, or sorry, we'll copy this and divide it by air dampener. Yeah, so now basically we can set our air dampener to be equal to 2 so that when we're in the air we'll move 50% slower. And if we jump, you can see that we don't move as fast as when we are on the ground. You can see if I hold down the W key, I'm actually going to move really fast, but when I'm in the air I'll move slower, and when I hit the ground I'll move faster again. And yeah, so the air dampener part is totally optional. Actually everything is optional, but these are like the settings that I suggest you add onto your rigid body controller. And I try to make this as customizable as possible, just so you guys can like obviously customize this to whatever will suit your needs. And yeah, so now let's actually move on to the final part, which is making our camera rotate as well as our player. So what we're actually going to do is we're going to go back into our script here, and inside void update we're going to actually want to declare some stuff. So we're gonna set, we're going to create a new variable called current rotation, as well as a new variable, and this is also, by the way, this is going to be a private vector2 variable. And we're gonna call this current rotation, and then we're gonna have 2 more new floats, and we're gonna call these the max Y angle. So this will be the clamp that kind of like limits how high and how low you can actually look on the y-axis. And we're also going to have a float for sensitivity. Sensitivity. There we go. I can spell it, guys, I promise. But yeah, okay, so now let's actually go back into void update, and what we're going to do is we're going to type in current rotation dot x will be added by input dot get axis else x times our sensitivity. And then we're just going to do the same thing but for y, and obviously instead of getting the axis from mouse X, we're going to do it from mouse Y. And again, we're going to multiply by sensitivity. Oops. And we're going to set the current rotation of X to be equal to mathf.repeat current rotation.x and then 360. And then we're going to actually set our current rotation.y to be equal to mathf.clamp current rotation.y, and then the negative of the max angle y, max y angle, and then the positive of the max y angle. And again, this basically clamps down our values so that we can't actually look more up or more down than we're actually supposed to. And then we're gonna actually, yeah, we'll find the main camera. Unless you guys have like other cameras with the main tag in your scene, then that's not good. But I'm assuming you guys only have one main camera, so we're just gonna find the main camera. We're not gonna make like another variable for this. And we set the rotation of the camera to be equal to quaternion.Euler current rotation.y for the, and then current rotation.x, and then 0. And then finally, we're gonna set the rotation of our player to be equal to quaternion.Euler 0 current rotation.x, and then 0. Oops. And then 0. Oops. Yeah. Yeah, so now we can go back into Unity, and what's going to happen is we're going to first set our camera that we added to our player to be the main camera, and second, actually I'm pretty sure, yeah, we don't really have any variables to fill, so yeah, we're actually no, yeah, we're pretty much done here. One more thing, actually, I'm going to make it so that this is also like a staple in most FPSs, but upon starting the game, you should generally hide your cursor. Wait one sec. Cursor lock state. Cursor dot lock state is equal to cursor lock mode dot lock. Okay, there we go. And then I believe it was cursor.visible is equal to none or false. Yeah, there we go. And then basically what this will do is it will lock our cursor to the middle of our screen and not show our cursor. And what this will allow us to do is it will allow us to basically not look at their cursor, and it creates a much more clean look. But as you can see now, my player is rotating to where I am pointing my mouse at, and he is also he or she is also rotating towards which way I point my mouse on the x-axis, and my camera is also moving around with my mouse, and also moving and jumping and running and doing all that stuff as well. Yeah, so that's pretty much the basics of how to make a rigid body controller. If you guys want to see me do a character controller based first person controller, I'll be happy to do that in another video. But for now, this video is over, and I'll leave the code for this controller in the description below if you guys want to go copy it. I do highly suggest you actually watch through the video though, so you learn something. But if you don't want to and you don't have time, then obviously the code is in the description below. But anyways guys, thanks for watching, have a good day, and stay coding. I'll see you guys.